Good morning, everyone.
Hey, Stuart.
Boy, it's nice to see so many people logging on. There must be marks associated with you guys being here today. Okay, so this is the start of the days that I've really been looking forward to, because I get to sit and listen to you guys talk and present for a while. So how this is going to work is that I'm going to go down the list, and I'm going to ask the people in the order that they're set up to do the presentation. It's not necessary that you turn the camera on during the presentation. If you want to, that's fine as well. I need to give you permission to share your screen. So potentially there may be a bit of a glitch with that till we get that down pat. But I will work on that. So just let me. Okay, so it looks like essentially what I have to do is I have to allow everyone to share the screen, but we will have it where just the person who's actually presenting will share the screen. So the first one on the list, going by alphabetical order, is Dennis Badurina. Hopefully I pronounced your last name correctly, Dennis. Are you all set to present?
I'm ready.
Okay, so just let me just.
Is my audio good?
Yep, I can hear you fine. So I'm assuming that everyone else. Okay, all right. So you should be able to share your screen if you're going to show us your presentation.
Okay, can you see this?
I can, perfect.
Okay. You can see it full screen?
Yep.
Okay.
No, it's for once Zoom seems to be cooperating with us. So yeah, I can see, and I'm assuming everyone else can see it as well.
Yeah, can Zoom play videos like on YouTube?
Okay. So every time I have tried, it hasn't worked, but give it a shot and see if it will work. Maybe if it doesn't work, if you post in the chat the link to it, then maybe potentially people could quickly go to the link.
Okay.
And that's yeah.
I'll try playing them. If it doesn't work, I'll just, like you said, I'll paste it in the chat.
Okay.
Okay, so my presentation is on tailing ponds. And sorry, someone has their mic.
Yeah, whoever, let me just give me one sec. Navdeep, can you mute your mic?
Oh yeah,
Let me just hold on one second, Dennis. Can I? Navdeep, if you can hear me, can you mute your mic?
Should I just keep going?
Just give me one second, because that is actually very distracting. I'm just trying to go through. There has to be a way that I can.
Okay, it's muted.
Okay, looks like we got it. Okay, sorry about that. So go ahead, Dennis.
So tailing ponds are man-made ponds made to hold tailings, and tailings are the byproduct waste of mining. So pretty much where you take an ore from a rock, the waste from that process is tailings. and they consist of clay, sand, water, silts, hydrocarbons, bitumen, that's pretty much oil, asphalt, salts, and trace metals. And here's a tailing pond here at the corner. Here's a bigger scale of one. See how massive they are. Tailing ponds in Canada. There are 3 major tailing ponds in Canada. A big one is in Alberta, some in Saskatchewan. But the Alberta one is pretty big. If I can click on this link here. How do I do this? Hopefully this works. So this site shows the total volume of the tailings. As you can see, it's about 1.7 trillion at the moment, or it's reaching there.
So
And,
Dennis, are we supposed to be seeing
oh, you don't see anything?
no, so we're not seeing it. So you may actually have to stop sharing this one and then go to the
Different
page that that you're actually attempting to show. No, then yeah,
Is this
so
now?
ship. Yep,
Oh.
there it goes.
So there's the total volume of the tailings in Alberta. There's this almost 1.7 trillion. There's the total costs of cleaning these up. And you can see the number just rising. And let me stop sharing this. So why are these concerning to the environment? Oh wait, you can't. Wait. So why are these concerning to the environment? They're filled with metals such as arsenic, cyanide, mercury, and other heavy metals. Stuff like copper, zinc. The tailings can damage the surrounding environment through the soil or water, and these have the potential to leak, which I'll talk about in a second. So these are some incidents relating to tailing ponds. In 2008, Syncrude, I think is how you pronounce that, had a problem with ducks. Over 600 ducks landed in one of these tailing ponds, and as you can imagine, the water is very dirty and toxic, and over 1,600 ducks died. And whenever animals are involved, it gets on the news, and people saw these pictures. And I believe a few years later, they were found guilty of not doing more to deter the wildlife from the ponds. Now, on the topic of leaking, Mount Poly, some of you maybe might remember this, in 2014, Mount Poly mine had an engineering problem. One of the dams broke down, and the tailing pond leaked to the surrounding lakes. And hopefully this link works. It was a brief summary of.
So you have to share that screen again, Dennis. So share the.
Can you see this?
Yep.
Tell me if the video is choppy. I'll stop it.
Yeah. See, no audio.
No audio.
Yeah.
So pretty much, but you can see this, right?
Yep.
All right. So it was pretty much a map of what happened. I believe this happened over a day or two after leaking to Mount Poly Mine, Poly Lake, Dazatin Lake, and then Glacial Lake, which, is a pretty mass area. And then so on. As you can imagine, this took a while to clean up and a lot of money. So Here's a better view of the incident. Or here's an ad, actually.
So this is the second YouTube video. So remember, you need
Okay,
to
yeah, share it.
just reshare that.
So here's a better view. This was taken, I think, moments after, maybe a few hours after the incident. So you can see the leaking spread. So yeah, this was a pretty big problem, as you could probably see. So what's being currently done? So you can after tailing ponds are finished being used, you can dewater them, which pretty much you suck up the water, lowers the water content in the ponds, and you can dry stack them, which is, you stack them and they can't really leak. They're more solid. And something else you can do is, sorry, I forgot to put it here, but you can, after the pond is in use, you can reuse the soil and use it for underground mines. Pretty much you can, fill in space that's not in use. So you can deter wildlife from these ponds. Something that's pretty popular is they use noise, really loud noise that sounds like jet engines or something like that. And it scares away the birds. They fly and they hear the noise and they fly away. Scarecrows, which is pretty much here on the right. You can see they work the same way as farm scarecrows, they think as a person, they fly away. And lights. This is, I think, mostly for owls. Owls see the lights and they get scared and they fly away. So more safety measures to prevent failures. As you could probably guess, this was a big priority after the Mount Poly leak. There was like I said, there was an engineering problem and it was inspected properly. So something they're doing is more inspection and backup plans if the surrounding dam does burst. The worst possible scenario. So yeah, that's my presentation.
Okay,
Any
so
questions?
so does anybody have any questions for Dennis?
I do. Does there happen to be like any sort of regulations for treating these before they and like treating the effluent streams? Because I'm assuming that's where it comes from. Is there any like sort of regulations that basically say that they have to treat the metal waste prior to being in these tailings?
I know there are I don't know of any specific regulations, but there are. I wish I saved this, but there are processes where you can treat the water with some sort of chemicals. I can't give you specifics. I'm sorry.
Yeah, I think from my experience with tailing ponds is that where the tailing ponds are located, based on the jurisdiction that they're in, that they have to go through some form of environmental approval to have those tailing ponds, and those approvals set out, what can be in the tailing ponds and what the end plan is for the tailings pond. So there are at least approvals surrounding these tailing ponds. Thanks for doing that presentation, Dennis. Tailing ponds are they're a big issue. Unfortunately, Dennis's presentation was a bit choppy, and I understand that because Zoom is not the best way to do this, and I really need to try and resolve this issue about why we cannot hear audio. I was just curious, just for one question from me, Dennis. Did you look at some of the treatment systems in any detail?
I did, but I didn't save them.
Yeah.
So
Okay.
I
So
wish I did.
yeah, I do know out at Syncrude, they're looking at treating the water with in the tailing ponds with various, even though there is, part of the tailing ponds is the is the soil component, but they're actually looking at using various types of clays to try and pull the hydrocarbons out of the liquid, and then treat those treat the material that's recovered, right? I think with the Alberta tailing ponds, one of the biggest issues is the hydrocarbon content, right? Because as Dennis pointed out in his slide in 2008, you have these very large flocks of birds that are migrating. All they see is liquid. They come down. They attempt to land on the pond for the night. And even though Dennis did go through a couple of mitigation measures, they're somewhat limited in their effectiveness. You will always have birds attempting, especially waterfowl, attempting to land in those ponds. And the other thing that because you guys know me, I'm always harping on about academic integrity and ethics. As Dennis pointed out, two engineers were just recently went through their misconduct hearings with the Professional Engineering Regulatory Body in British Columbia, and I believe both those engineers have had their licenses revoked, or at least they're under
They
some
were
type of.
they were fined.
They were fined. Do you know, was
Yeah.
their license revoked?
I believe one
I think the
2018.
I think the senior engineer license was revoked, and the junior engineer was put on some form of probation. So
That was this year, I think.
yeah, it was just very recently. Okay, so thank you for your presentation, Dennis. Any other questions before Dennis stops sharing his screen?
I have a question. It's kind of general, but I was wondering, how long if you know, like the Mount Poly incident, like how long did it take them to clean up, or at least like make it so that it was less toxic to like it got into the lakes, like the marine life and like everything. Like, do you know roughly, like, are they still working on cleaning up, like the consequence of the dam breaking, or? Like, because I guess it's happened now, like 7 years ago.
So I think in 2015 they saw a big improvement in the surrounding lakes because they noticed that the fish were adapting to the pollutant. But I don't think they're still cleaning it up unless maybe Stuart can correct me on this. But
yeah, I'm not 100% sure if there is actually still a cleanup going on. You have to look at what occurred from that leak. And yes, it did go to I believe it went to a lake, then another lake, then to the rivers. Once it's in the rivers, I mean, essentially over time that flushes itself out as you get closer back to the source of the leak. It becomes more difficult because you're dealing with sediment. So I'm not sure if there is actually any ongoing remediation, but it was a significant. There was a significant remediation had to be undertaken as part of that. We were just very lucky that I don't believe there were any human fatalities surrounding this. There has been some very large releases, where they've been so large that have been human fatalities associated with it. So yeah, tailing ponds is just there's something that we really need to deal with better than we do. Okay, so thanks again, Dennis, and we're going to move along. If you want to stop sharing your screen, we're actually some people for various reasons were unable to present today, so we are going to continue down through the list. Some people from tomorrow have been are going to bump up, and we're going to go to one of them right now. So Kristen, I believe that you're ready to present.
Yeah, I'm ready.
Yep. Okay. So let's do your presentation.
Can you see it?
Yes, we can.
Okay. So my presentation is going to be on CNL, which is the Canadian Nuclear Laboratories, and we're going to focus on the Chalk River site. And Chalk River is about 5 hours north of here, right on the Ottawa River. So about CNL in Chalk River. So CNL is Canada's leading nuclear research and technology organization, as well as a global leader in the development of nuclear technologies for peaceful and creative uses. CNL is also repairing and conserving the environment, improving sustainable energy, and CNL is also advancing in the medical innovations which continue to enhance the health of people all around the world. So what is waste? As per the Canadian Standards Association website, waste is defined as a residue material generated as a result of a process, operation, or activity that has no further use in that process, operation, or activity, and is declared for reuse, recycling, or disposal. So the waste process at CNL, it starts with planning. So this includes any assessment of the waste, the type of waste it might be, the volume, how it was developed. Then we move into the generation. So then all the waste is generated. And at CNL, if CNL produces the waste, then CNL will also dispose of this waste. And this waste can range from like small lunch trash, like your granola wrapper, all the way up to radioactive waste. So transportation. Waste can be transported from at any stage during the waste management and can be transported between CNL sites. So CNL has places all over Canada. So they have a site in Saskatchewan, I believe, and that waste from Saskatchewan can be transported to any of the Ontario sites. Processing. Anything that changes waste characteristics in any operation is considered processing. And storage. So sometimes CNL will put waste into storage, but when they do put waste into storage, they put it into places where they can still reach this waste if they require to be accessed. And then disposal. So sometimes CNL will put some of their waste into long-term storage, and they do this in case they can develop a method to get rid of their radioactive waste in the future. So other waste generated at CNL. So CNL generates clean waste, hazardous waste, mixed waste, and radioactive waste. So the clean waste is the non-hazardous material. The hazardous waste is material that is potentially hazardous to the environment and human health. The mixed waste is a radioactive waste that also contains hazardous substances. And then the radioactive waste would be waste that is produced from nuclear fuel. And another thing that I found during my research is at CNL, only 6% of their total waste is radioactive. The rest is clean, hazardous, or mixed. But we're going to look at a little bit more at the different levels of radioactive waste. So they have low-level waste, intermediate-level waste, and high-level waste. And these are just the different levels of how radioactive they are. So low-level waste is material with a long-lived activity in limited amount. Intermediate level waste is penetrating in radiation in significant amounts. And high level waste would be the nuclear fuel produced from radioactive waste. And in this diagram, it just shows you a little bit more where all the different sites in Canada are and what kind of radioactive waste is at each site. So down in the bottom corner here, you can see Chalk River, and they deal with all different types of radioactive waste. So future waste. So CNL, so some waste that is produced now is stored for future use in case a method is developed in the future to get rid of the waste in an eco-friendly way. And this waste can be stored in 4 different types of storage. They can be stored in modular above ground storage, shielded modular above ground storage, a bunker, or fuel and packaging storage. And then this is the life cycle of some of the waste. So the waste would start with being uranium, and then it would move into smaller elements. And these elements would go down into free particles, and then heat would be added to generate power through spinning a turbine, because steam will rise and turn the turbine. Next, the spent waste goes into a cooling pool, and then the waste is sealed off into dry cases. And these are the dry cases that can be stored underground or in any of the different types of waste storage areas. And these also can be held for long periods of time until they can develop a new method to get rid of these in an environmentally friendly way. So CNL also has an environmental policy, which they are responsible for the environmental management, pollution prevention, and pollution prevention is defined as the use of processed particles, materials, products, substances, or energy that avoid or minimize the creation of pollutants and waste and reduce the overall risk to the environment or human health. Their policy also includes improvement to environmental objectives, clean energy, to follow environmental laws and requirements, to continue to develop environmental protection technologies, and to promote the policy to all of their employees and the residents surrounding CNL. CNL also has an environment plan, which they want to manage the radioactive waste they produce. They want to monitor and manage their emissions. They want to upgrade their current operations to a more eco-friendly way. They want to build new places to evolve and develop new methods to get rid of radioactive waste instead of just storing it underground. They want to improve their waste management, and they want to have a sustainable way to operate. So this would be like offsetting their carbon footprint. And they also want to conserve resources to improve performance. And then at CNL, they also have the integrated waste strategy. So the integrated waste strategy at CNL was made with government policies, laws, requirements, environmental health and safety in mind with how to regulate their waste. The purpose of this system is to have a defined pathway for waste from generation to disposal within CNL with 3 main parts of significance. The first one is what is happening right now. The second one is where do we want to be? So where do they want to be in the future? And the third one is will be how will they get there? So how will they create a new method or a new way of disposing things so it doesn't just get stored underground or in or in a storage facility. And then that's it. Those are my references.
Okay, thank you very much, Kristen. That was actually quite interesting. Does anyone have any questions for Kristen?
I have a question.
Okay.
Go ahead.
You mentioned that they were storing their waste underground. Is there a maximum amount of time that they will allow that to stay underground before they come up with a recycling plan for it? Or could
So
it be there for centuries to come?
the waste could be there when I was doing my research for hundreds and hundreds of years, because they're not sure how or if they will ever be to create an environmentally friendly way to dispose of this. But if they do manage to create a method or develop one, they want to be able to get rid of this instead of just leaving it underground. So it's not a permanent solution, but it's the only thing that they can do right now.
So so for instance, with the underground tanks, will they be monitored to ensure that the waste isn't being leaked out over the hundreds of years, or do they just
Yeah,
bury it
so
in-
they're in forget exactly what they said, but they're kind of like double sealed containers. So they've got like a ceiling on the inside and they have a ceiling on the outside, so none of the waste leaks, but they do go down and they manage all the different types of radioactive levels in their waste bunkers and everything.
Awesome. Thank you. That's really cool.
Thank you.
So is that waste being stored at Chalk River itself right now?
So some waste
Kristen?
can be stored there, yeah.
Yes, so you said some, so where's the rest of it going?
So some can be, others can be stored in third parties who can store it for them, or different storage places across any of the CNL locations across Canada.
Yeah, so is CNL, are they, I guess they're actively involved in this deep geologic storage facility up
Yes.
on Lake Huron, right?
Yes.
Yeah, because it seems like that is something that seems like it's going to go ahead, even though there's a lot of opposition to it up in the area. But I mean, to me, it seems like a logical way to deal with it right now until something better comes along, right?
Yeah, when I was doing my research, CNL was also, I believe, was partnering with the federal government and OPG to look at different ways to store their waste together, because it's both nuclear waste, and then develop a plan or a method and then share it with each other when they do create one
Yeah.
to get rid of all the waste.
Yep. Okay, perfect. Thanks very much for doing that, Kristen. Great job. Okay, so I believe the next person on our list is Jack Burrows. Jack, are you ready to go? Is Jack even with us? Okay, we'll move ahead, and we will go to Will Chaplow. Are you ready to go, Will?
Yeah, I'm ready. Can you hear me?
Yep, very faintly. Navdeep, if you can hear us, can you mute your microphone, please? So it has to be. Okay, go ahead, Will. You should be able to share.
Is it any better?
Yep, that's much better.
Okay, let me just share screen. Okay, can you see that?
Yes, we can.
Okay. Okay, good afternoon, guys. My name is Will, and today I will be presenting to you about using chemistry to recycle plastics. I'm going to start the presentation by talking about mechanical recycling of plastic, which is considered a more traditional method. I'll talk about some pros and cons of using chemical recycling, and I'll discuss why chemical recycling is largely underused in Canada and the US. So starting with mechanical recycling, this is the physical sorting, cleaning, grinding, melting, and remolding of plastics to produce generally lower grade plastics that are then resold or used on the market. Mechanical recycling facilities are currently the most favored and funded in Canada and the US when compared to chemical recycling. Now, despite the amount that they're used and the support mechanical recycling gets, there are some glaring issues with this process. The first is the profitability. The market in general is considered non-profitable at this point because virgin plastics or plastics that have not been on the market before are cheaper to buy than plastics that have been recycled. So there's no real incentive for companies to invest or put their money into this industry when they don't see a way that they're going to get any money back out of it. Mechanical recycling of plastics is only effective for 2 out of the 7 types of primary plastic that are on the market. So there's a lot that gets untouched by this. And there's a massive reliance on foreign recycling programs when it comes to mechanical recycling. In my research, I found a large percent of the plastic waste we produce in Canada and the US gets shipped to a lot of different Asian countries, primarily China. It was for a long time. I came across a report in 2018 where China basically banned or reduced almost to zero the amount of plastic waste they are accepting from Canada and the US because the bulk that we were shipping and due to contamination and problems with the sorting of the recycling, it was becoming a profitability issue for them. So this will lead me into chemical recycling. And this is the use of chemical reactions to break down the plastic waste at a molecular level and recover these raw materials, which are used to manufacture new plastics, oils, fuels, or waxes. So it's kind of a complicated procedure, and it would take me a long time to explain how this works in detail, but there are three general methods that are used in chemical recycling, which are hydrogenation, gasification, and pyrolysis. And they involve treating the plastics with chemicals in very controlled conditions, usually controlling the heat and oxygen. And it allows them to produce byproducts that are considered virgin quality and can be resold back to plastic manufacturers, reused to make brand new plastics to go on the market. I included a visual of sort of the breakdown of how it works to look at. And I've also included a visual of the 7 types of plastic. It goes according to a numbered system in North America, I believe worldwide actually, but you can see mechanical recycling only deals with PET and PEHD, while chemical can deal with all 7. This leads me into the advantages of chemical recycling. As I mentioned, it has a potential to treat a much higher proportion of the plastic waste that we produce. It's more time efficient than mechanical, and it has the potential to handle larger quantities at once in a shorter period of time. It does not degrade the plastic through the process like mechanical recycling does. And it promotes a circular economy in the plastic industry. And to explain this, I included a visual here from GAO that shows sort of how a circular economy can be established here on the right side, from the product manufacturing to consumer, to plastic, to chemical recycling, to virgin equivalents, which go directly back to the product manufacturer, versus in a mechanical recycling facility, it would go from recycling back to the consumer at a lower grade and would have a shorter lifespan before it essentially ended up being recycled again or disposed. Some disadvantages of chemical recycling: facilities require significant startup cost, and it's expensive to operate day to day because of the solvents they use, chemicals, and expensive instrumentation and whatnot. There is an environmental risk inherently that comes with using these strong organic chemicals. And they need to take consideration into how they're going to dispose of these chemicals at the facility and import them and whatnot. And unfortunately, they face the same non-profitability issue in our market due to the cost of new plastic materials being so cheap to produce and buy. I included a figure on the right from 2018 Wall Street Journal. Unfortunately, this was the most recent I could find, but you can see from 2010 to 2015, the cost of recycled PET remains significantly higher, or significantly higher than new PET. And the cost of these virgin plastic materials has continued to go down from 2015 to today. I just don't have a visual to show it. The controversy of chemical recycling. So many environmentalists, and I was coming across this in my research sort of on discussion boards and posts online. There's a lot of people that try and sort of take a stand against chemical recycling, usually with the idea that our biggest problem in the plastic industry right now is not enough material being recycled, most of it being destined for landfill. And some people consider chemical recycling sort of an expensive distraction from what this main issue is. And if we can start diverting plastic waste and prevent it from going to the landfill, that should be our first and primary goal. Some people also question the process of turning plastic waste into fuels in a society that is supposedly moving away from fossil fuel use. So in conclusion, the plastic waste stream is a complicated issue that will require coordinated effort from nations working together. It's not going to be one process can fix it all or handle all the issues presented. But it's my opinion that chemical recycling could play an important role in the future of our recycling programs in North America. I think if we continue to discourage the production and use of virgin plastics on the market through regulations, taxes and whatnot, we may provide the financial incentive that some chemical recycling companies need in North America to begin making a profit and begin building up sort of larger companies that can operate on a commercial scale. I included a figure just out of interest from the Canadian Council on our strategy for zero plastic waste that was signed in 2018 by the Canadian government. It's aiming for a completely circular economy with regard to plastics in Canada by 2030. This is a very long document. I won't pretend that I read through the whole thing, but I did find mentions of chemical recycling being utilized moving forward as a part of this plan, and many other things working together. And it really is questionable whether we will reach the goals that are set out in this executive plan, I believe they call it. But it's interesting that chemical recycling of plastics is being recognized by the government as a useful tool moving forward. Additionally, I listed 4 companies here on the bottom. Just if anyone's interested, you can look at them and see some of the work they're doing. Agilyx is a chemical plastic recycling company based in Oregon in the US. Plastic Energy is a UK-based company that is actually doing commercial scale chemical plastic recycling, but only in Spain. And then for 2 Canadian plants, I've listed Renewology Pyrolysis Plant, which is in Nova Scotia, and Green Mantra, which is in Brantford, Ontario. And these are both smaller facilities that are not operating at a commercial scale. So that's everything I have for you. Thank you everyone for listening, and so I'll take any questions now.
Okay, thanks, Will. That was very interesting. Any questions for Will?
I have a question, always.
Okay.
I'm just
Okay.
curious, with the chemical aspect, where does the waste go? Like, where does the chemical waste go that you've treated the plastic from?
So yeah, that is part of the argument against these facilities. They will be responsible for disposing of any chemical waste that they're producing during that process. And I'm not sure whether it would be more profitable for them to ship their waste off site to have it to do solvent recovery and reuse the chemicals, or whether they would send them straight for disposal. But it is correct that either way, that is a downside of using chemicals. There is going to be some sort of disposal of solvent that's required by these facilities.
And what about the materials that's recovered, Will? So does that go right back into, so if they recover polyethylene, does that go right back to be reprocessed into virgin or new?
It would often have to go to a refinery first, and it also it depends on exactly what type of material they're recovering, because as I mentioned, sometimes they use recovered materials for oils, waxes, and fuels rather than plastics. So I think they would go to a different facility if that was the case. But plastic materials, I believe, need to be refined before they can be sold back to the manufacturer.
Yeah, I think the long game with plastics is to do what the CCME document says and get to a net zero plastic use of plastic materials, because how you deal with the plastic at the end of its life, it's a real challenge. And like you pointed out, in 2018, China slammed the door to a large amount of the recycled plastic that was being generated in North America. So what do we do with that material now, right?
I wonder the same thing.
Yeah, like what is happening to it. So, okay, well, thank you very much for doing that, Will. Can
I
you
have
stop?
I have more of a statement if this topic
Okay.
actually does interest you. We did a presentation in material science on, did you happen to come across supercritical water liquefaction?
I did not know.
No? Okay, so it's essentially like breaking down plastics into its like constituents, because plastics are polymers.
Mhm.
And you can repurpose that into creating either more plastics or to creating fuel. And that might interest you if you wanted to research it.
Okay. That does sound familiar. I just don't know that term. I probably I might have read that and skipped over it. It was too long or something, but
It's
I will look
similar to
into it.
like thermal cracking, catalytic cracking. Yeah.
Okay, let's try and get one more in. Will, yeah, you can stop sharing your screen there for a sec, right, Will? Because when you do that, I lose.
I'm ready to go, Stuart.
Okay, so who is this?
Matthew.
Okay, Matt. Yeah, if you could go for whatever reason, when Will disconnected his screen there, I have now went to a blank Zoom screen. So if you could go ahead, that would be perfect. Hopefully my screen will come back.
All right, do you see that okay?
Megan, can you indicate if you can see that? See,
We can see it.
yep.
Okay,
Okay.
great,
So
thanks.
looks like I'm the only one that can't see it. So yep.
Oh.
So go ahead. Okay. Just
Well,
go
if you'd
ahead.
rather, I can go tomorrow then, so you can actually see
No,
my presentation.
that's fine. I'm going to ask you to post it anyway. So
Okay.
I'll take a look at it. Okay.
All right. Well, I'm also covering topics. Today, I want to talk to you guys about how Canada has a very large plastic problem. So our nation is responsible for contributing a large portion of the globe's growing stockpile of plastic waste, but we've been incredibly negligent with our methods of disposal and reuse. Canada's management of the plastic industry's waste creates some very costly problems. So Canadians use 1.4% of all plastics produced annually. That's an estimated 4.6 million metric tons per year. And yet we take up less than 0.5% of the globe's population. But that's fine because many plastics can be recycled, which allows for the repurposing. And we all recycle our waste, right? Wrong. Canada only recycles an estimated 9% of the country's plastic waste, or about 305,000 metric tons of mixed plastics. So what happens to the rest of Canada's plastic waste? About 29,000 metric tons is leaked into the environment. 137,000 metric tons is incinerated, which contributes to our air pollution. And a whopping 2.8 million metric tons ends up landfilled. Canada also has a history of turning their plastic waste into someone else's problem. Canada, among other countries, has taken part in shipping their waste off to foreign nations to have them act as their dumping grounds. 12% of Canada's plastic waste is shipped outside the continent to be recycled, or so they claim. But most of the country's plastic exports get sent to Southeast Asian countries, which often lack the infrastructure to properly handle the waste. So these plastics end up collecting in foreign landfills or just being incinerated. In the past, about half of Canada's recycling exports were shipped to China. Canada, among other nations, contributed towards China's importation of 45% of the world's waste. But China found themselves disposing of more imported waste than they could recycle due to the amount of contamination from food waste mixed in with the plastics. Most of the imported plastics had to be burned and landfilled along with other types of waste. But in January of 2018, China proposed a ban for the import of many of their solid wastes, including different types of plastics. This ban caused multiple developed nations, including Canada, to begin exporting their plastic waste to other Southeast Asian countries instead. These other nations continued the trend of burning and dumping plastic waste, as it is more cost-effective means of disposal, but it's just terrible for the environment. Some of these nations have spoken out about their use as Canada's dumping grounds. As recently as 2019, Malaysia denounced Canada, claiming Canada has been irresponsible with their plastic waste exporting. Malaysia has been shipping containers from Canada Malaysia has been sent shipping containers from Canada under the guise of being recyclable plastics. But what Canada actually sent them was containers filled with plastic bags and product packaging that was just too contaminated or of insufficient value to recycle. So essentially, Canadian waste exporters lied and sent Malaysia their undesirable trash. Malaysia refused to accept the shipment and they sent them back. In order for these global impacts to be properly addressed, Canada needs to start moving towards a goal of having zero plastic waste produced annually. Not only is it environmentally friendly, but it's an economically sound decision as well. Remember how I told you about 2.8 million metric tons of Canada's plastic waste materials were sent to landfills? Well, they alone result in about $7.8 billion of lost potential profits annually from failing to recover the plastic materials. But zero plastic waste cannot be achieved without government intervention. This rather ambitious goal requires a systemic change to multiple private and public sectors for any hope of being achieved. There's 5 sets of government interventions that are proposed. They're determined to be effective in reaching this goal. First is the creation of stable end markets for the recycled materials. These markets allow for the resale of recovered plastics, and they improve access to the country's domestic supply of recycled materials. Next, we need to get everyone to want to collect plastics by creating collection requirements or incentives for companies, restricting disposal, and improving recycling information available to the public. Next, we want to improve support and expansion for value recovery options, such as improving mechanical and chemical recycling mentions, like Will mentioned. Fourth, we want to increase the efficiency of the operations by educating any actors and consumers involved throughout the chain and investing in sorting and separation to improve the performance. And lastly, we want to extend the lifetime of plastics to reduce waste generation by promoting reuse, repair, and remanufacturing of materials through standardized reusability requirements and tax exemptions. Without Canadian government intervening, positive change to the recycling system is unlikely to happen. Thanks for your time, guys.
Okay, thanks, Matthew. Unfortunately, I still have a blank screen. I will watch the recording, and hopefully the recording has worked. Does anybody have any questions for Matt based on his presentation? No, nothing. I think what we've seen from the last 2 presentations is that, you know, plastics are really problematic. I think with the change in the 3 hours regulations, that's going to put more of the responsibility onto producers. Hopefully, we'll see some of these, new ways of dealing with plastic material and preventing it from becoming a waste will take place, because when you put money on the table, that is quite often what drives industry. So hopefully it's something that Canada will get much better at. Okay, all right. I think the people who are presenting tomorrow have got a bit of a challenge ahead of themselves. I was impressed with the presentations today, and thanks for everyone who did them. And we will get going again right at 8 o'clock tomorrow morning. Okay, so any questions from anybody before we go?
I have a quick question for you, actually.
Oh, for me? Okay.
Surprising, isn't it?
Yes.
So I'm
What?
just curious. So
Yeah.
after all these years, Canada obviously knows that plastic is terrible for the environment. And they've
Yeah.
set out these dates, for instance, where grocery stores are no longer allowed to sell you plastic bags.
Yeah.
However, there are still some grocery stores that do sell you plastic bags. So
Yeah.
why are these dates implemented, but then not followed through for the companies to actually follow the guidelines set out?
You know, it all comes down to enforcement, and Canada. Essentially, how our enforcement activities work in Canada is we tend not to come down with a big hammer on these on people who are breaching environmental rules and regulation. You know, we go along the approach of voluntary compliance, where government will slowly try to bring these non-compliant individuals or companies into compliance. When you talk about things like plastic bags, I'm amazed that there's still stores out there that will sell you plastic bags, because that seems like such an easy one to crack down on, right? But you will always get companies that will, you know, skirt around whatever regulation that is out there, and that's part of the challenge for the government, is how to bring these companies into compliance without significantly impacting the economy at the same time. So yeah, it's definitely a challenge.
But in a sense, it does impact the economy. Like something, I'm going to talk more about it in my presentation, but the government has actually given them millions and billions of dollars to bail them out from their deadline. So for instance,
Oh.
we're given a deadline and then it's like, oh, well, here, I'm going to pat you on the back and give you $5 million because you can't abide by the regulations we've set out. It's very confusing.
Don't get me started on that one, Megan. There are so many examples of companies who are, you know, grossly non-compliant with environmental legislation, managing to get government grants. So yeah, it's that is a big problem, and I look forward to you discussing it a bit in your presentation.
I'm very, very upset about it, but
Yes, I can tell. I can tell. Okay, we're 6 minutes past noon, so I don't even know if we actually have a whole bunch of people still on the call, because I can't see any part of my Zoom screen. But thanks everyone for attending, and thanks for those who presented, and I look forward to hearing the presentations tomorrow. Okay, thanks guys.